Okay, let's dive right into how to master Cluster 3 on climate. We're going to walk through exactly how to nail question 3 on your geography paper step by step.
So we're going to tackle this exactly like the exam question itself. We'll break it down into 4 phases. We're starting with the science, the atmospheric mechanisms. Then we'll get into the marine and terrestrial impacts, and we'll wrap up with the really big one, evaluating the adaptation strategies.
All right, first up, Part 3A. This is all about the physical geography, the why behind the weather. Specifically, what causes relief rain.
Okay, so it all kicks off with something called a topographic barrier, basically a big mountain range right by the coast. Now, this barrier forces air to move upwards, and that process triggers the orographic effect. You absolutely need to know that term. It's a guaranteed point score.
And this effect creates 2 totally different zones. On the windward side, you've got moist air coming in from the sea. It gets pushed up the mountain, it cools, and bam, it condenses into a whole lot of rain. But on the flip side, the leeward side, that same air comes down, it warms up, and gets super dry. This creates what's called a rain shadow, which is why it stays so arid over there.
Right, so now that we get the cause, let's look at the consequences. Parts 3B and 3C are all about the huge domino effect these climate patterns have on our ecosystems.
Let's start in the ocean. Coral reefs are basically the rainforests of the sea. They're the foundation for so much marine life. The problem is they are seriously threatened by our changing climate, and that puts the whole underwater world at risk.
And this is the part you really need to remember. Climate change attacks reefs in 3 specific ways. First, you've got thermal stress. That's rising sea temperatures literally causing coral bleaching. Second is chemical, ocean acidification, which makes the water corrosive and weakens their skeletons. And finally, there's kinetic force, stronger, more frequent storms that just physically smash the reefs to pieces.
And on land, it's a similar story. Drought kicks off a 2-phase collapse. It starts with what we call biological starvation. Plants die because there's no water, and that messes up the entire food chain. And that leads right into phase 2, physical destruction, because all that dead, dry vegetation becomes the perfect fuel for massive, catastrophic wildfires.
Okay, this brings us to the final, and honestly the most important part of the question, 3D. This is where you have to evaluate how we as humans are actually responding to all these massive threats.
And here's the core question you have to answer. Are these big, hard engineering solutions, things like seawalls and dams, are they really the most effective strategy we have?
Well, the main argument for these big structural projects is pretty straightforward. They give you immediate, powerful protection. Things like detention tanks and seawalls physically stop hazards like flash floods and sea level rise. They're like our frontline defense for protecting lives in our cities.
But here's the flip side. These concrete solutions are rigid, they're static. They can't easily adapt as climate change gets worse. Plus, they cost a fortune to build and maintain, and they often don't balance the economic, environmental, and social needs you need for real, long-term sustainability.
So, if just building giant walls isn't the whole answer, what else is there? Well, there are a couple of other paths. You've got technological solutions, like advanced warning systems that can save lives, or precision irrigation to save water. And then you have social adaptations, which are all about people. Things like teaching communities how to handle heat waves or training farmers to plant crops that can survive a drought.
And the thing that holds all of this together, that's the institutional backbone. We're talking about government policies, regional agreements. These are the things that provide the funding, the rules, and the coordination to make all the other strategies actually work. Without them, it's just a bunch of small, disconnected projects.
Now, this table right here is pure gold for your evaluation because it lays out all the trade-offs. You can see it clearly. Structural gives you that immediate protection, but it's super rigid and expensive. Tech is proactive, but you need the infrastructure to support it. Social strategies are amazing because they empower people, but changing behaviors takes a lot of time. And finally, the institutional stuff provides the scale, but, it can be vulnerable to politics.
So, how do you pull all of this together to write a top-scoring final answer for the exam?
Here's the bottom line. No single strategy is a silver bullet. While hard engineering is great for immediate threats, the most effective and sustainable approach is always multi-pronged. The best answers will argue that you need to combine all 4 pillars, structural, technological, social, and institutional, to create a defense network that's strong, flexible, and truly resilient.
Okay, think of this as your master revision sheet.
To absolutely nail this question, you need 3 key things. First, know the difference between the wet windward slope and the dry leeward slope. Second, understand the domino effects on both marine and land ecosystems. And finally, for that big evaluation question, you have to argue that true resilience comes from integrating all 4 strategies together. Get that right, and you are well on your way to a top-tier answer.